I am Professor DATAWAREHOUSE, Professor of Statistics, Acharya Nagarjuna University. Today I am planning to talk on Big Data Analytics Sensitization Program, and I am going to introduce the topic at an elementary level. Let me introduce the distinction between big data and high dimensional data, and let me explain the meaning of data analytics and data analysis, the distinction between data analysis and data analytics. And to have this, let us take a spreadsheet having say P attributes and N sample size as given in the slide. And in spreadsheet notions, as you know, the attributes are represented by means of columns and the samples are represented along with the rows. And when the data is given and doing some sort of statistical calculations and drawing conclusions is called data analysis. Then what do you mean by data analytics? In statistics we have several tools, and at elementary level all of you are quite familiar with measures of location, dispersion, correlations, regressions and whatnot. So these calculations and making interpretations is called analysis. Now, given a situation, application, and if the existing tools in the statistics literature, if they are not sufficient, and if we need to go for new set of tools, then that is called data analytics. Rather, devising new techniques, tools and adding to the literature of statistics is the subject of data analytics. Now, coming to big data. If number of samples are very large, then such kind of situation is called big data situation. And big data analytics, in such situations, if existing tools are not adequate to analyze the given problem, then such a situation is called big data analytics situation. Then, if number of attributes are very large, and such kind of situation is called high dimensional situation. And in high dimensional also, if the tools are not adequate, then we try to devise new techniques and new tools, and such kind of situation is called high dimensional data analytics. And there are certain assumptions in high dimensional statistics. And the basic assumption in developing the existing tools is that the sample size is sufficiently larger than the number of parameters or the number of attributes in the given situation. If it is other way around, entire statistics literature, whatever tools that are available, all of them they collapse and they cannot be used in such kind of situations. And altogether we need to develop new technologies, new techniques, and that kind of situation is called high dimensional data analytics. And I hope you are very clear about the distinction between big data analytics and high dimensional data analytics. With this background, let us proceed further. And now people are talking, there is a fever about big data analytics in every sector. It could be software or industrial data analysis and whatnot. Now, if you look at Excel sheet, MS Excel, how many rows and how many columns are there? And this MS Office 2003, if you look at, can you guess how many rows and how many columns are there? Now you can see. In 2003, the number of rows are in a given situation, the sample size can go up to 65,536, whereas number of parameters or number of attributes or number of columns and that the MS Office can support is 256 columns. And as we are talking about big data analytics, and this number is not sufficient, Therefore, MS Office has enhanced its facility in 2007 or 2010, 2013. If you look at the number of columns or number of attributes is 16,384, and whereas the sample size can go up to 10,48,576. Now, for big data analysis, is this spreadsheet sufficient for us or not? Let us see. If we are dealing with a scientific problem in bioinformatics, as you all know, each individual will have genes, genetic factors, genes will range from 50,000 to 1 lakh per individual. And what is the Indian population? 1.252 billion. And it is something like 10 to the power of 9 or so. And if we think of analyzing the genetic problem, bioinformatics problem for entire world population, then what will happen? And the spreadsheet that is supported by MS Office, will it be sufficient? Definitely it is not sufficient. And this is the trivial example of big data analysis. And in such situations, the existing statistical techniques may not be sufficient to analyze the problem. Therefore, there is a need for the data scientists to design, devise new tools, techniques, and hence there is a need to develop big data analytics. And that is the main motivating factor for the upsurge of this particular subject of big data analytics. Now, people are talking that big data analytics is a very recent subject, maybe is of 10 years or a decade old. Is it really true? If we can look at this particular sloka, its meaning is, we all know that there are 4 Vedas: Yajurvedamu, Samavedamu, Atharvana Vedamu, Rigvedamu. These are the 4 Vedas. And for these 4 Vedas, there are again Upanishads attached with these 4 Vedas. And this is the problem in Dwapara Yuga. Prior to Dwapara Yuga, Krita Yuga and Treta Yuga, we have assorted enormous amount of knowledge, and people in those 2 yugas were intelligent enough to understand all those assorted literature. But when it comes to Dwapara Yuga, and people were not in a position to comprehend this enormous literature. Therefore, in Dwapara Yuga, Krishna Dvaipayana, who is very much familiar as Vyasa Maharishi, and he has, with the help of his 4 students, Paili, Vaisampayana, Jaimani, and Sumanta, he has classified entire literature that is existing into several classes as
Vedas and Upanishads, and number of branches of these Vedas are 1180.
And if you look at this particular sloka and list of,
we have are 108, and if we look at the sloka, the list of all 108 Upanishads are given there, and the list is
presented in each Veda. How many Upanishads are there is depicted in this particular table. Rigveda 10 Upanishads, and then Yajurveda 19, and Krishna Yajurveda 32, and Samaveda 16, and Atharvana 31, 108, and the list is as follows: 108 Upanishads. This is the list of all those Upanishads. And not only Vedas, Upanishads, and some more literature is available, and they are classified as Brahmanalu, Aranyakalu, Brahmasutralu, Vedangalu, and in turn Vedangalu are further classified into Vyakaranam, Niruktam, Jyotisham, Kagara Shastram, Kalpam, Mimamsa, Nyayamu, Sapta Pramanamu, and so on and so forth. Is it not the big data, further Jyotisham, Siddhantam, Hora and whatnot? So the idea of big data is very much known since Dwapara Yuga. It's not a new thing. So, but the fever of big data in the present situation of industrial development and whatnot is of recent one. But the ideas of big data and analysis of big data is very much known since Dwapara Yuga. Now, we all know multivariate analysis. And if you look at multivariate setup, and the spreadsheet is identical as what we have depicted in the very first slide of big data analytics. And in multivariate analysis, we all know from statistics knowledge, we have correlation analysis, modeling aspects, pattern recognition, data reduction, canonical correlations, conjoint analysis, multi-dimensional scaling, etc. The list is not exhaustive. And all these things we know, the systematic analysis part of it, we know very much. Then, what is the specialty of big data analysis? And where is the need to talk of analytics in big data? Because very much the tools are available under the topic of multivariate analysis from statistics literature. And let us see the need for big data analytics. And as far this multivariate data analysis is concerned, we deal with only numeric data. And with the advent of internet, what kind of data that is available nowadays, if you can see, within numeric, we have categorical data, binary data, transaction data, symbolic data, time series data. Fine, all these things maybe to some extent we can deal with the existing literature, with the existing techniques. But how about text data? And if you look at your Facebooks, Twitters, and all these social media, and we have text data. And by means of this particular thing, if you want to analyze the psychology of individuals, posting various types of things in the social media, and one has to analyze it, and it is no more numeric data. And apart from that, people can exchange images, videos, speeches, and various curves, surfaces, and whatnot across the internet. And there is a very need to analyze this, and the tools that are available in statistics literature, they are not meant for analyzing this kind of non-numeric data. Therefore, we need to analyze multivariate data, and the same techniques we have to apply. But the question is, how we can extend these techniques to non-numeric data is the subject of big data analysis. Therefore, necessary transformations are to be made to transform this non-numeric data into numeric data. Once that transformation is done successfully, and the problem comes into our control and our domain, and multivariate data analysis can be applied comfortably. But when it comes to high-dimensional data, no, all these things further they may fail, and new technologies are required. And where is the situation of high-dimensional data? And one classic example which you can think of is cancer data analysis. If you look at, and there are several parameters to tackle the problem of cancer disease, and to design new drugs, we have several parameters. How about samples? Samples are nothing but the patients that are coming to the hospitals. And how many cancer patients you can have to study various parameters in medical science. Definitely, this is the situation of high-dimensional data analysis, for which the existing statistical tools will collapse and will not help us to analyze the data successfully, and therefore there is every need to design new techniques, namely to develop analytics for high-dimensional data analysis. Similarly, for big data analysis, for non-numeric data, we need to design new technologies, new techniques, and that is the motivating factor for this new upcoming area of big and high-dimensional data analytics. And in addition to the medical example which we have quoted, what are the other domains of big data? Digital library and we can see it's a very big library across the world, and we can exchange the literature from one place to another place, and it's extraordinary. Similarly, all these things which are listed there, image archives, bioinformatics, medical imagery and health care, finance and investment, manufacturing and production, business and marketing, telecommunication and our networks, and of course www, web pages, and biometrics, identifying individuals, and all these things in all these domains we come across the applications of big data analysis. Therefore, it is a vast subject, and all these areas will deal with mixed type of data, both numeric and non-numeric, containing all sorts of categories which we have listed. And therefore, new set of techniques are to be developed, and it is the job of data scientists. It could be statistics scientists or computer science people. With the help of domain experts, we need to develop this kind of situation. And therefore, it is clearly an interdisciplinary activity. For example, if we take biometrics, and main object of biometrics is taking the measurements of the human being. We have to identify that human being uniquely, and that is the basic application of biometrics. So if you look at the criminology, if some offense has taken place in a particular place, then we need to identify the criminal and with uniqueness. This is the application of it. Then what is that we can have in this particular situation? Then we try to pick up the measurements on the probable criminals, and we try to verify with the records that are available with the police people, and thereby we try to confirm who could be the culprit or the criminal. This is the application. If we look at this particular application, and it is purely an interdisciplinary area, because we need to develop instruments to do it instantaneously. And to develop these instruments, let us examine what are the fields that are required. If you look at analysis, for the purpose of analysis, we need the subject of statistics. And after making the modeling and doing all these things, sometimes we may have to evaluate, in this particular example, we may have to evaluate multiple integrals and with improper ranges, improper multiple integrals, and which statistics fellow may not be able to solve perfectly. Therefore, he has to seek the help of mathematicians. Then fine, once we have solved this particular problem to the logical end with the help of mathematicians, then is it all? And one has to develop the algorithm, and that is the job of the statistician. So once the statistician with the help of mathematician finalizes this particular algorithm, then the question is, this computer scientist will come into the picture, he will try to prepare the software for it based upon the algorithm that is given by these two people. And will it be sufficient? And if you look at this particular biometric data, and these two people, mathematicians as well as statisticians, they will not be able to make out what are the features that are required to analyze this particular problem. What are the measurements that are to be taken on this particular individual to solve this particular problem is a big question mark. For example, if biometrics is to be solved based upon fingerprints, certain type of variables are to be taken. If it is to be analyzed with iris data, taking iris measurements, a particular type of analysis is required. If it is facial type of analysis, taking the facial measurements of the individual to identify the individual uniquely, another type of analysis is required. Similarly, DNA and the way he walks, gait, and depending on the type of problem one has to tackle, and different features are to be taken, and it is beyond the scope of statistician as well as mathematician. Therefore, it has to depend on the people from medical sciences and who are thorough with anatomy. Only anatomy people will be able to give this particular information, what kind of measurements are to be taken. So therefore, up to this, it is the interdisciplinary area of mathematicians, statisticians, and anatomy experts. And is it all? No. Ultimately, we have to develop an instrument with a click of mouse. We need to do it instantaneously, the job. And for that, what are the other things that are required? We need to have electronics engineer, and we need to have electrical engineer. We need to have a mechanical engineer to develop that box and whatnot. And we need to have electronics and instrumentation fellow to have it. Is it all? Again, ultimately, all these things are taken with the help of images. I mean, fingerprint is taken as an image, or a photograph is taken through his face and whatnot. Therefore, again, a specialist, computer specialist is required who has the knowledge of image analysis. Therefore, all these things, big data problems, if one is really need to solve to the logical end, it is an interdisciplinary field. So each category of problem requires a different set of interdisciplinary experts. Only it can be solved with the help of several people, and therefore all these projects very much need interdisciplinary, and therefore universities and educational institutions, they should have to encourage only interdisciplinary activity, and nowadays it is done on paper but not in reality. And once we have captured the data, enormous amount of data, how the data is to be represented. And computer science people, they are quite familiar. Ultimately the data has got to be, for the purpose of analysis, it has to be represented in the form of a cube, a multi-dimensional cube. Then only we will be able to do it. And this particular thing is called, this is the job of data warehouse experts, to design this kind of a thing, how it should be. It is the job of computer experts, and that too data warehousing people. And what are the advantages of having this kind of structure? The advantages is we can do operations comfortably on this slicing. Wherever we want to cut the cube, we can cut it, and only that particular dimension of the data can be analyzed depending on the application that is posed. Dicing, drilling up, drilling down, drilling within, across, and pivoting means rotating the things in across different dimensions. These things are possible only when we are able to design the data structure, a big data structure or a two-dimensional data structure in terms of hypercubes. Then only further operations based on developing computer software will become possible. And these operations are called OLAP operations, online analytical processing operators or operations. And ultimately, the design architecture is of this sort. And crude data we try to have it, and that we try to push it into warehouse, and where these things are stored, if we want to know it, we need to develop metadata, and then these are to be accessed and analyzed, and that can be done with the help of OLAP operations. And then taking the particular layer where it has to be analyzed, we try to apply statistical tools, we analyze it, and then finally we give the results for the users, clients. And this is what we nowadays call data mining. So advanced data mining, you can call it as big data analytics, where you incorporate new techniques into the modules automatically. This is the broad structure of data warehousing. There are several other kinds of architectures. It is beyond the scope of this particular thing, because I am after a statistics professor and may not be knowing the details of it. It's only to give a glimpse of idea. And then OLAP engines, there are varieties of engines and they are listed there. And again, one has to maintain metadata where the data is stored in different layers and whatnot, we need to have it, and therefore metadata is required. For example, in a complex situation like Acharya Nagarjuna University, and if one has to do it computerization process and whatnot, then we may have to deal with accounts, administration, affiliation, establishment, distance education, international student centers, and student profiles, hostels, and whatnot. We have several things. Therefore, for all these things again, number of variables will be there. What kind of variables we are going to have for each type of things, and that is called metadata maintenance. So on one side we need to have metadata maintenance. If we can pick up this metadata thing, it will point to the place where it is stored in the warehouse, and from that we have to pick up and then analyze it, data mine, and do it. And here, if we have complex varieties of data variables and variable types or data types, then definitely it is a case of big data. And if analysis tools are inadequate, then we have to go for analytics. This is what we have. And when it comes to servers, and if we need to have it, enormous amount of data will be available, and if such a kind of problems are to be developed for entire world, across the world, then a single server will not be sufficient. This is a typical location of huge number of servers in US National Security Agency. This is taken from internet. So therefore, do you mean to say that only US is using this kind of a thing? No. Even in India, if you go to CDAT and CDAT, they are having this kind of enormous amount of servers distributed across India at 70 different places, and we can have remote login to various places. But again, the students must be familiar with this kind of technology, and this kind of facility is very much available in Acharya Nagarjuna University, and Acharya Nagarjuna University is a member of NKN. With that, we can access CDAC servers through our engineering college. So it is very much available in India. It's a question of developing technology for these big data applications. And let us see a small case of it. What is the objective, scientific objective of big data analysis? Big content explosion, and with the advent of internet, there is explosion of data, and therefore we need to provide contextual and relevant information for the user, and that is the need of the hour. This is the object of big data. Let us have a simple application. Massive sample size with high dimensionality. Massive sample size allows us to unveil hidden patterns associated with small subpopulations and with weak commonality. What does it mean? The meaning of that is we have to categorize the huge data into small subgroups or clusters in such a way that within the subgroup, within the cluster, the variation should be less, and between the clusters it should be more. Therefore, within the cluster it should be homogeneous, and across the clusters it should be heterogeneous. That is how we need to design the algorithms to classify the massive data into different groups. And this particular problem is called cluster analysis. And excellent algorithms are available in multivariate data analysis to solve this particular problem. But the question is, if the data is having various kinds of other data types other than numeric data type, then can we apply the existing algorithms that are there in multivariate data analysis is a big question. That's a thing we need to investigate. And if we closely go into cluster analysis, let us see what happens. And cluster analysis, let us have a simple problem. I have 25 objects, and my aim is to divide those 25 objects into 5 groups. This is a simple problem. Can anyone answer how many ways it can be done? Let us see in how many ways it can be done. This problem, 25 objects divided into 5 groups, can be done in those ways. Perhaps I failed to pronounce the number. These many ways it can happen. Therefore, manually doing this particular job is humanly impossible. But how many objects, how much of data we have in big data analysis? As we have already quoted so far with several examples, bioinformatics, biometrics, and several examples. and we will have terabytes, zettabytes, that kind of data we'll have, and we need to design them into several groups. Therefore, the number is enormous, and hence automation is required. Therefore, algorithms are required. In general, if we have n objects and if they have to be divided into m groups, and it can be done as per that particular formula. This is what we have. So the next question is, what are the logic of developing algorithms? That is to be investigated. And therefore, up to this, I have given only introduction, and my main lecture, the outline of lecture will be cluster analysis, classification, challenges that are there in big data analysis, what are the curses, what are the blessings, and impact of statistical thinking, new thinking is required, impact of computational, and impact of computing infrastructure. And these are the aspects we have to discuss, and my further capsules will have all these things, and I'll touch upon all these things in the subsequent classes. And I have picked up the material from these sources. It's not my original thing. These are the differences.